So the following tutorial will outline how to create an assay, in this case a transcriptomics assay. The previous tutorials have covered how to create an overall investigation, how to define the different samples, characteristics, and treatments. And then using this information, we can now define an assay. So here I'm clicked on this assay. This is the transcriptomics assay. So the starting point are the samples that we defined. So for example, the first sample we've defined was the TG Gates in vitro. The test compounds was doxorubicin, control, 8 hours, 1. So let's use that. And what we're seeing here is a series of steps. So the first step is the RNA extraction. This is a protocol, and again, as we did before, this will be linked to a protocol defined on the TOXBANK data warehouse. The next is then this, so you would just repeat all the different samples. So here we can see the technical replicate 2. It's not been defined already, but if it was, you can see that. So each of these samples will then refer to the samples that we defined earlier. I'm just clicking back on the study in this column of the study. And each protocol then creates something. So in this case, it's named the extract. So the sample, we do the RNA extraction, it'll create an extract. And you could call these terms anything that you wish. You could even, for example, call it, I'll just edit this and add extract. The next step again is to label. And again, this is linked to a protocol in the data warehouse as we defined in the previous tutorial. And again, this will create another step, and this is named. So in this case, we could call it labeled extract. In this case, it's actually asking for a particular label. So here we can type in the label that was used. In this case, it was biotin. And here it's defined under the Kebi ontology. So we'll just select biotin. Again, the next step, nucleic acid hybridization, linked to the protocol. This then takes the labeled extract, creates a new name. So I just call this assay. If you've got the design ref, we can include that. So in this case, the design ref was HGU. Oh, that's not right. And then we start collecting the data. So this will then, the next step is it generates a scan name. And the scan name, again, you could perhaps relates to the experiment you ran. In this case, the scan name was 30161000023. Now, the underlying data that was generated is not included in the ISA creator metadata. What we're doing here is we're describing the experiment. The underlying data is in external files. So in fact, for this experiment, it generated a cell file. I'm just going to copy this from the spreadsheet. And this we add into the array data file, the cell name. And this is a file that's in the directory that we're creating this investigation in. Now you may have done further processing of the data. So here we've just filled in one of the columns, but what you'll have is a separate, one row of this table. But you could have well, you invariably will have multiple samples that have been tested at maybe different treatments, different time points, different doses, and you can repeat this process going across. For example, if biotin was used in all the different samples, I just click on that term, and then this little button at the top is quite useful to say copy biotin for every single sample because it's all been repeated. So here we've linked it to the individual cell file, the transcriptomics data file. Now we may have done more processing, and we may have even combined the data. So for example, we've gone through a normalization data transformation, and I can show you an example of what that looks like for this experiment. So here you can see that in this normalization file, the different probes and data, each corresponding to the name that was in the Assay creator. So here you can see a direct link between the data and the meta information in the Assay creator. And each one of those would correspond to the names in the Assay creator, this normalization name. The final step is you may even have done some more sophisticated transformations, for example, looking at the control at 8 hours versus the control at 24 hours, or looking at comparing doses at 8 hours versus a dose at 24 hours. And what we've developed is a standardized way of deriving that information. And I can show you an example. So here we have for each of the genes, we've linked it to an ensemble or entree or symbol. And then we have, for example, the low at 8 hours versus the control at 8 hours. What's the fall change? Or what's the p-value of that fall change, or q-value? So these are showing p-values, q-values, fall changes, and they all relate to comparing different tests that have been performed. And this term here, you can see low at 8 hours versus control at 8 hours. This will be part of this data transformation name. So you may have combined 6 or 8 different cell files to create that. And those would all have the same name. So in this case, it would have the name low dose at 8 hours, control at 8 hours. Each of those individual cell files, so you're actually combining, in this case, 6 cell files. You're giving them the name, and then to link that information, again, we don't store any data in the Assay creator or this meta information. But what we do is we will link it then to the underlying file. So I have the underlying file here. Just copy it. And it's just a single file which relates these different fall changes, p-values, q-values to the genes based on this experiment design. And again, it's a single file across all the different tests, so we can use this useful function to copy the file, the link to across all the different tests. So that summarizes how we can manually create a transcriptomics meta-information by linking the data, defining the experiment, defining the protocols. Finally, if there are any additional parameters that need to be added to any of the steps, there's a button here. You can add a parameter. You can search for the parameter. It could be a qualitative or quantitative value. you may have to also link it to the units, but that's if you wanted to add additional parameters to the data, it can be done as well. So that concludes this tutorial on creating a transcriptomics assay metadata.